Okay, are you ready to do some torque problems? Oh my gosh, we got the Brady Bunch here. And they're all sitting on a teeter-totter. Now, it's not to scale because I just had to make this problem up from a picture that I found on the internet. But here's what we got. We have Bobby weighs 100 newtons. He doesn't weigh 100 newtons, right? But I'm just using that to be easy. And he's 4 meters from the fulcrum. We have Peter who weighs 200 and he's 3 meters from the fulcrum. We have Greg who weighs 250. He's 2 meters away. And then, of course, Mike is 1 meter away. And he weighs 300. On the other side of the teeter-totter, we have Carol, and Carol weighs 150, and she's 2 meters away. And then we have Marcia sitting there, and she weighs 120, and she is 4 meters away. And then, of course, no, it's Marcia. But Jan is 6 meters away, and she's 100 newtons. And how much does Cindy weigh? And that's what we're trying to figure out here on this problem. So what does Cindy weigh? Now, to do torque, of course, is the force that's perpendicular times the distance from the pivot. That's what torque is. It has to be the distance from the pivot. That's why I have it drawn the way I have it drawn. Okay, we're going to make this into an equilibrium problem. We're going to make sure that everything that is making it torque counterclockwise is equal to everything that it's making it torque clockwise. So I'm going to draw it in a pattern that I like to use where I'm just going to draw everything that's going to make it torque the one direction on one side and everything that makes it torque the other direction on the other side. Now, I could make this all equal to 0, blah, 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 but I think this is a little bit cooler. Okay, so Bobby's force or his weight is 100, and he is 4 meters away. That's my first one, force times distance. Plus, Peter is 200, and he's 3 meters away. Greg, 250, and he is 2 meters away. And Mike is 300, and Mike is 1 meter away. All right, that's the side that goes to the counterclockwise. And then let's switch colors, right? Let's do orange. So we have Carol's 150, and she's 2 meters away. Plus Marcia is 120, and she is 4 meters away. And Jan 100, and she is 6 meters away. Cindy's weight is unknown to me, and she is 8 meters away. All right. Now, we're going to resolve that out. Now, you know me. I just do the algebra in my head, right? So, in this case, I won't do the algebra in my head, but I'll do a quickie algebra type thing here where I'm on that side of the equal sign, so I'm going to move all these oranges over by subtracting them from the other side. See what I'm doing there? Yeah, math teachers, take that. And I just moved that equal sign over and made it all equal like this. All right? So I really subtracted those torques from both sides, and they all ended up on the left. All right, and then that's ready to punch in. Oh my goodness, I didn't bring my calculator down here. 400 plus 600 plus 500 plus 300 minus 300 minus 480 minus 600 equals F times 8. All right, so you're going to subtract those all up on the one side. What do we have here? 10,000, 15, 18, right? 18 minus 3 is back to 15. 1020, and then minus 600 would be 520, right? So 520 divided by 8, sorry about the sloppy math, is going to be equal to her force. I hope I have a calculator on this thing. clear. Where's the clear? What did I say? 520 divided by 8 equals 65 newtons for baby Cindy. And I hope that helps. I'm sorry I didn't have a calculator, but that's probably pretty close to being right. I did it as fast as I could without double checking myself. So that's all you would do. All right, you make both torques equal, then solve for your one unknown. You can only solve for one unknown on this thing because that is the mathematical law. Okay. Oh, we have a lady on a bridge. She's looking down the valley and just having a great old time. Now, the key to these problems, a bridge problem, is to pick a side that you want to make your pivot point. I'm going to pick this side. You know why? Because things are measured from that side, and that seems nice for me. Okay, so we work this a lot like a teeter-totter. Everything that makes it pivot to the pivot clockwise, right? So this, her weight, the weight of the bridge, both make it pivot that way, and the only thing that makes it pivot the opposite way would be that rock right there that the bridge is sitting on. Okay, so we have, let's change the color of that. The only thing we have the other way is this rock right here. Okay, so let's start off with our purple. So we have 2 times 750 plus the bridge weighs 500, and it's halfway in between, right? We're going to assume that that's halfway because they're not saying anything different. So 5 times 500, and then that's going to be equal to the force that the rock or the other side of the bridge is pushing up, and then it is 10 meters away from that pivot point. Remember, everything has to go from the pivot point. All right, and so 2 times 750 plus 500 times 5 divided by 10. 1750. And that's the force FB is pushing up. Okay, now you want to find the other side. You have two options. You can just reverse and do everything exactly the opposite we just did. Or we can realize that if FB is holding up 1750, then that doesn't seem right. Let's try that again. Clear. 2 times 750 plus 500 times 5 equals divided by 10. I got 400 that time. What happened? I don't know what happened. Okay, so I'm saying 400. You know what? We all make mistakes. I hope that's the right thing. I'm not looking. I can't see the numbers when I get the calculator on, so that's my problem. Not a good problem. All right, so as I was saying, we could find that just reversing the whole problem. We can do the same thing just backwards. How would I do that? Oh my gosh, I would just go backwards. I would make FB my pivot point, and I would say that the bridge center still 500 newtons is 5 meters away. And this time the girl is 8 meters away, right? From here to here, 8 meters times her weight, 750, and it's equal to FA times 10. And that would work out, and you can do that. Another way of doing it is just finding the total weight of the whole entire bridge. So 750 is her weight. The bridge is 500. We add those together, and we find that that's 1250, right? 1250 total, and 400 of it is being held up by FB. So subtract that off, and that has to be what is being held up from side A. All right. So, for you non-believers, 5 times 500 plus 750 times 8 divided by 10 equals 850. 850 FA equals 850. Hey, what a coincidence. It matches. So either way works out. I don't care which way you do it. If you don't care, that's your bridge. Right? All bridges work that way. You have to use everything on there. If the center of mass it isn't marked, it's probably the center of the bridge. Oh my gosh, we have something on a hinge, and luckily it's all marked. Oh my goodness, can I do this in my head? So we're trying to find the force of the tension in this cable here. So we have the hinge right here. The hinge is where it's going to pivot, right? So the only thing that's making it, remember, it has to be perpendicular, that's making it not pivot is this force that's perpendicular right here, right? And then from that we'll find that triangle. Okay, so let's go and make this thing work out. Do I have distances? Yes, I do. So 80 newtons times 1.5 meters. Boom, boom, boom. Plus 120 newtons times that whole length there, which is times 3, equals that force perpendicular created from that cable, which, oh, that's an ugly number, is going to be F perpendicular times 2.38. Okay. So I need to punch this into the calculator. I don't even have a pencil to write down what I'm going to try to do. So I'm going to do 80 times 1.5. Clear. 80 times 1.5 equals plus 120 times 3 plus 120 times 3 divided by 2.38. All right, I got 20. Let's call it 202. So the perpendicular force equals 202. All right, now that's this. We want to know what the cable is. That cable's at a 35-degree angle, right? So that's 35 there. So we can also say, well, you can find two sides here. I'm going to use this side right here. Look at that. That has to be 35 degrees too, because my geometry teacher in 9th grade told me so, right? So we have that going on. So that's sine. It's an opposite. So let me write everything out the normal way. Sine of 35 degrees equals the opposite side, which is 202, over whatever that hypotenuse is. Now I'm solving for the hypotenuse. That's on the bottom of that fraction. So if it's on the bottom of that fraction, I need to get it to the top. And I'm just going to use like cross multiplication. That's what I call it. I don't know if it's really called. But I'm going to move that h to the top. Keep that 202 where it's at. And then bring that sine of 35 degrees to the bottom. So I'm taking this up. I'm bringing this down. Okay. And so 202 divided by the sine of 35. 202 divided by, and I got to do this backwards on this thing, I think. And I got 351.16. So let's call it 352. And that's your force at the angle. All right, I hope that helps. That's 3 torque problems, the teeter-totter of the bridge, and then a sign hanging. I couldn't see any other kind of torque problems that couldn't be adjusted from these 3 things right here. This should take care of most of your problems. All right.